weeks ago, my girlfriend decided to take me to this antique shop, and now my basement is filled with a bunch of old antique tools, hand plane saws, some hand crank drills, all kinds of stuff like that. But it's all stuff that probably spent a lifetime sitting in somebody else's dank, dark, dismal basement, and it's all covered in rust, so it needs a little bit of TLC to get it back in working order. Anyway, I did a little bit of research, and I thought that electrolysis to remove the rust might be a fun thing to try. So I did it. I have a hand plane right here that I restored using that process. Let me see if I can get a little bit closer. All right. So I used electrolysis to get rid of the rust on all the pieces of this hand plane, including the lever cap, the chip breaker, the plane iron itself, and most importantly the sole. If you look at the bottom of this thing, it's not 100% perfect, but it's got like a mirror finish on it now. It's very, very smooth. The only part that was left on here that I thought was an issue were these pock marks along the edge, where it actually did remove the rust, but of course it left little divots. And I lapped this thing with about 5 different types of sandpaper until it got this mirror finish on it. But these were still here, but I read that won't really interfere with planing anyway, so that's not a big deal. I then refinished it in black. I didn't do the classic Japanning like they did on these Stanley hand planes. I just used black spray paint. I'm really more concerned with preventing rust than I am with being, historically accurate. So that's why I went with that. So basically, rust occurs when iron, water, and oxygen come in contact long enough to cause oxidation, which results in the chemical compounds that we can see and call rust. And since we know what causes rust, we ought to be able to prevent it, right? Yeah, you paint a metal surface or you treat it with some sort of wax or other protective coating, yada, yada, yada. But what we're worried about is what to do about rust after the fact. And that's how I came to discover the process of electrolysis. Arthur C. Clarke said that any sufficiently advanced technology is completely indistinguishable from magic. And I kind of think the same thinking goes for just about any scientific process when it's witnessed without enough information. That's kind of how I approach this entire thing. I watched video upon video and read tutorial upon tutorial on how to do electrolysis to remove rust. And yeah, it worked, but I didn't really understand what was going on, and so I kind of felt like it was unsafe, and maybe I shouldn't be connecting a car battery charger to water. That just seemed, logical to me. Anyway, so I did a little bit of research, and it turns out it really is kind of like magic, because you need a sacrifice and a bubbling cauldron to make this whole process work, but I'll get to that in a minute. Basically, electrolysis is the process of using direct electrical current to drive a chemical process. Basically, in this case, the process is reversing oxidation in iron and iron alloys. Now, rust occurs in other metals as well. I don't think the same process works in other metals. So, iron, steel, stainless steel, etc. You need a couple of things to get going with the whole process. The first thing you're going to need is a tank. You're going to need basically something made out of plastic or some other material that's not going to interfere with this process. One of those big plastic bins you can get at department stores, or a 5-gallon plastic bucket, they would work fine. The next thing that you're going to need is some sort of rig to suspend your workpiece into it. Basically what I did was I used just a piece of wood, 2x4 or whatever, across the top of my tank, and then I used a little bit of mason's line to tie off to that bar and suspend my piece into the solution that we're going to talk about here in a second. The next thing you're going to need is some source of power. I used a car battery charger with an amp meter, so I can monitor how much electricity is going through this thing at any given point. I bought that for a couple of bucks at a local hardware store. I really think until you're all said and done here, everything you should need for this project might cost like 40 bucks. The next thing that you're going to need is something called an anode, which this is the sacrifice that I was talking about earlier. Basically, kind of in geek speak, the technical term anode is an electrode through which electricity flows into an electrical device. So this is where your source of power, the positive lead from your source of power, is going to connect into this whole apparatus. The anode, I mean, it sounds technical, but it's really just another piece of iron or stainless steel. Actually, you don't want to use stainless steel, and I'll get to why later on. But it's another piece of iron or steel that you're going to drop into the tank or tub or whatever you use for this, and it's going to attract away some of the parts of the rust, basically. Basically, the anode is where the positive lead from your power source is going to connect, and when the whole apparatus is turned on, the iron oxide, which is basically our rust, it's going to attract out the oxygen to the anode, and what's going to happen is the anode is going to start getting rusty, because once again your anode is made of iron. It's attracting oxygen in a big tub of water, so yeah, that's going to cause rust, and it's only going to be useful for so long or so many trips through the electrolysis process, so it's a disposable, sacrificial piece of the process. The next part of electrolysis is you're going to need an electrolyte solution. Again, that kind of sounds really technical, but basically you just make it by combining 1 gallon of water to 1 tablespoon of washing soda or baking soda. Pretty simple, and you'll basically fill your tub to the point where you can submerge your workpiece, but it's not so filled up that it's going to overflow when you drop the workpiece in. So basically 1 gallon of water to 1 tablespoon of washing or baking soda, and that's your electrolyte solution. Basically, it's just a solution through which the current from your positive and negative leads can flow through. You don't need to really understand it any more than that, I guess. Finally, the last thing you're going to need for the process is your rusty item, which is the cathode in the electrical circuit, or where the electricity flows out. That might seem kind of weird that you want your electricity to flow from that other piece, the anode, through the water to your good piece and back out, but that is actually how this works. And what's going to happen is, as the process works, the oxygen is going to separate out over to the anode. It's going to give off the hydrogen, and you're going to see it actually bubble up out of the water. So that's basically all you need. So I guess we'll go out to the shop and I'll show you how it's done. Alright, so I'm out in the shop now. I'm going to show you guys how to set up the process to remove rust using electrolysis. For example, this isn't even an old tool. This is just an old panel saw that I could replace for 10, 15 bucks at a department store. But I'm just going to use this as an example. So you want to have everything ready to go when you want to start. What you're going to need is the cathode, which is the rusty workpiece. You're going to need the anode, which is a piece of iron or steel that is basically going to attract the junk. Something to remember, I said earlier you don't want to use stainless steel. The reason is that stainless steel, when it goes through this process, creates another byproduct called chromium, which is very toxic. Once this process is done, you'd probably be breaking the law if you just dump the water with chromium in it, and it's a carcinogen. It can cause cancer, so obviously you don't want to come into contact with it. So make sure you're using iron or steel and not stainless steel. Somebody recommended to me in a forum to just use rebar. It's cheap and it's plentiful and it's totally safe. So stop by your department store, hardware store, whatever, and pick up some rebar instead of this, which was kind of expensive. Next thing you're going to need is obviously your tub. You're going to need your water to fill the tub, and you're going to need washing soda or baking soda to create that electrolyte mix, and finally your power source. I picked up this bad boy down at the local hardware store for like 35 bucks. Next thing, after you have everything ready to go, make sure you're being safe. Number one, make sure this thing isn't plugged in until you're absolutely ready to start the process. Don't work with power on. That's just totally unsafe. You're dealing with electricity and water. It's just kind of common sense to be
you know, as safe as you can possibly be. The next thing, wear gloves. You don't want to be coming into contact with this stuff. It's nothing too dangerous. You know, the washing soda can be a little bit hard on your hands, but you don't want to take any unnecessary risks. And finally, wait for it. Safety glasses. Alright, so first things first, we are going to dump our water into the tub. Now, I have my water measured out now already. I did this before, and I know that 10 gallons is pretty much going to give me what I need in this tub. So, 1 5-gallon buckets, 2 5-gallon buckets. We found a cleaner bucket. Next, you want to mix in your washing soda, and again, it's 1 tablespoon per gallon. And I did have a little measuring device around here somewhere. I don't know what happened to that. So I guess I'll wing it. But anyway, it's 10 gallons, so I would want 10 tablespoons. Oh, well, in freaking hindsight, there it is. 10 gallons, 10 tablespoons. Next thing we're going to do is put the anode into the electrolyte mix. I think I'm actually going to go ahead and turn it that way so that rustier part is to the back. We want to rig something up to suspend our workpiece in the water. I'm just going to do that with a small piece of 1x and a little bit of Mason's line. This stuff works great. It's super strong. Unless you're suspending something heavier than you can probably lift in this water, this line's not going to break. I take it back. I'm not ready for that. I need to get this this workpiece ready to put in. You don't want to put it in with anything that's not metal. So obviously I have to get rid of this wooden handle first. That's all right. So here we go. Now we're going to want to submerge this in the water in such a way that it's completely submerged, but it's not touching any of the sides. That's fairly important. So I'm going to go ahead and turn that like so. Maybe you guys can see if I do this from behind the table. Take some of this Mason's line, cut off a nice long piece. It's really cheap, so if you waste it, don't worry about it. We'll go ahead and just knot that off here. It's nice to tie this up in a way that you can adjust it a little bit after the fact. So don't make it overly tight. Put another piece on there. And by the way, this isn't exactly product placement. I don't care about the brand, but these knives are like the best thing ever. It's just it's a pocket knife that accepts a regular utility knife blade, pops in and out. It beats a regular pocket knife. It's always sharp, and when it's not sharp, you pop in another blade for 30 cents and make it sharp. They're super cool. Alright, so that's what I have here, and I'm going to tie the saw off to that. And conveniently, it's got holes drilled on either side, so this should be pretty easy. I say that now. There we go. Just knock that off. Same thing from the other side. make the strings pretty even. So I'll show you what I'm going to do here in a second. Alright, so I made that nice and long, and what I'm going to do now is just kind of twirl this up so it's a little bit adjustable this way, that's all. Now I'm going to submerge it, and yeah, that's pretty good. It's just out of the water and just above the bottom, that's perfect. One thing I'm noticing here is that I did not mix up the washing soda into the water very well, so I'm going to go ahead and do that real quick. I need something a little bit longer there. Push stick, perfect. Probably a whisk would make this task a little bit easier, but who has a freaking whisk in their wood shop? Alright, so, last but not least, we're going to hook the positive red to the anode with our alligator clip, and we're going to hook the negative to the workpiece. Now, I didn't quite understand it at first, but it makes sense now. The negative isn't an issue to have underwater. However, the positive is. So you want to make sure your anode is tall enough that there's a little bit sticking out of the water that you can hook the alligator clip on, so the alligator clip itself isn't submerged. Otherwise, if this is underwater, the exact same thing is going to happen to your positive lead as happens to the anode itself. It's going to corrode and be completely useless. So now that that's all set up, and I'm nowhere near it, I'm not touching this apparatus at all, I'm going to go ahead and plug it in. Alright, let the fun begin. Basically, in a couple of minutes, what I would start to see is there's going to be bubbles coming up off the workpiece after the process really gets started. I can't really see it yet. Just a little bit. Just a little bit. Maybe I can zoom the camera in on that a little bit. Okay, you can see it a little bit. There's bubbles coming up off of the workpiece. Basically what's going on there is this chemical process, it's going to attract the oxygen over to the anode and cause that to rust, and during that process it's going to give off the hydrogen from that molecular bond that causes the iron oxidization. So basically we would just keep an eye on it from here on out and check back in an hour or so and see what it looks like. At that point, after about an hour, what you're going to see is that the rust has kind of moved away a little bit, and in its place there's going to be kind of a black film on your workpiece. At that point, if you don't see any rust anymore, you can take it out. You're going to want to turn off the power before you do any of that, obviously. Turn off your power, you can take it out. If you need to turn it around to get the other side of the workpiece, you can do that and then plug it back in. Or you can just take it out and basically scrub it off with a cloth or a wire brush if need be, and you should be pretty well rust-free. Well, I hope this has helped everybody out. I know there's a lot of other videos on the internet of other people doing this stuff. I wanted to show you just a little bit more of a different perspective on it, give you a little bit more information about why the process works. I was just educating myself when I did that anyway. One other thing, when you're done with this, provided you used steel or iron to do this, your water should just be safe to dump out. You're not going to have anything that's really harmful in that water. It's going to be Just water, it's going to be your washing soda, which is something you would be dumping down the drain when you do laundry anyway, and iron oxide from the from the rust itself. However, if you used stainless steel, which I told you not to, so don't fucking do it, you don't want to dump that. In fact, you're going to be breaking the law, like I said before, if you do. So be very careful with that. Make sure you know what you're using. Don't touch any of this crap while there's electricity hooked up to water. That would be pretty dumb too. Just exercise some caution. And throw me a comment or a message or something. Let me know how you guys make out. I'm excited to see what you do with it too. Alright, I'll catch you later.